Hello mathematicians, thank you for joining me again today as we look at the integral of sine squared cosine squared dx. So now as we're trying to find this antiderivative, what we want to do is we first want to determine what technique of integration to use. So now if I look at this, I'm going to first ask, can I guess the answer? And in this case, no, I cannot guess the answer. So I would move on and say, is there an inside function? And yes, there is. There are actually two of them. There's sine and there's cosine are both inside the squared function. And so what I could do is I could try I is equal to sine of x dx. So di is equal to cosine of x dx. So dx is equal to di over cosine of x. And so if I substitute that in, I get the integral of I squared cosine squared x di over cosine x, which we can simplify to I squared cosine x di. Notice that in the process what we have is when we're done here, there are still x's in this integral. That is, we weren't able to get rid of all the x's by using the substitution, so we can't integrate this because we have two variables. Therefore, what that would mean is that we should go back and try a different technique. And so the next thing we should try is say, well, maybe if I try cosine as an inside function, substitution would work. But if we go through that process, we're just going to get a very similar thing where we're left with a negative sine of x di times I squared. And so in that case, again, the substitution won't work. So we're going to have to try something other than substitution in this case. Alright, so now that we know that we can't use substitution, we start back to the beginning. Again, we can't guess. We're not going to use substitution. So our next question would be, is this a product of functions? And in this case, yes. This is a product of functions. It's a product of sine squared and cosine squared. And as such, it is also a product of two trig functions. So what we're going to want to do is use our reduction formulas. But in order to use our reduction formulas, we need either sine to the n or cosine to the n. So the first thing we have to do is simplify this so that we can use those formulas. Now the way we're going to do that is we can actually pick either one of these, and we could say, well, I can write sine squared in terms of cosine squared, or I can write cosine squared in terms of sine squared. And I'm just going to choose to write cosine squared in terms of sine squared. And the way I can do that is, remember, cosine squared plus sine squared is 1. So cosine squared is just 1 minus sine squared x dx. And so if I want to find this integral, I can find the integral of sine squared times 1 minus sine squared dx. And then I can distribute the sine squared, and I get the integral of sine squared x minus sine to the fourth x dx. And now I can actually break this into two integrals. That would be the integral of sine squared dx minus the integral of sine to the fourth dx. And so what I'm left with is now two simpler integrals, either the integral of sine squared or the integral of sine to the fourth. On both of these, I'm going to have to use my reduction formulas. So I'm going to go about and actually do that. So now as we try to finish this integral, we're going to have to find this integral and this integral. So I split them up so we can focus on one at a time. I've also written up here my reduction formula for sine to the n, and we know that the integral of sine to the n is negative sine to the n minus 1x times cosine plus n minus 1 times the integral of sine to the n minus 2x dx all over n. So now what we need to do is just substitute in the n's for each of these and see what we get out. And so the integral of sine squared is going to be negative sine to the 2 minus 1 is 1 times cosine plus 2 minus 1 is 1 times the integral of sine to the n minus 2. So 2 minus 2 is 0. Sine to the 0 is just 1 dx all over n is 2. And so I get the integral of sine squared. If I do the same thing again for sine to the fourth, what I end up with is negative sine to the 4 minus 1 is 3 of x cosine of x plus 4 minus 1 is 3 times the integral of sine squared of x dx all over 4. So now I have the integral of sine squared minus the integral of sine to the fourth, and notice that now I have to finish this integral and this integral. So I'm going to continue with this process, and I'm going to end up with negative sine cosine plus the integral of 1 with respect to x is just x all over 2 minus, now I'm going to get negative sine cubed cosine x plus 3 times the integral of sine squared. Now sine squared, we're going to have to use a reduction formula again, but notice that we've actually already done that up here, so I'm just going to copy that. And so actually we've finished that one here, so I'm just going to plug this in as my answer, and I'm going to get negative sine x cosine x plus x all over 2. And then we're going to take that whole thing, divide it by 4, and so that's going to be the integral of sine squared minus sine to the fourth, except remember that this is going to be an indefinite integral, so we do need a constant of integration at the end. So I'm just going to put in a plus c here. And now we have found the integral of sine squared minus sine to the fourth. However, remember that this was equal to the integral of sine squared x cosine squared x dx as our original integral. So this is equal to this, and so we finally have out our integral using our reduction formulas. Thank you for joining me today, mathematicians. I hope you enjoyed this, and I hope you learned something along the way. If you did, make sure to like the video and to subscribe to the channel down here. This will help make sure that other people get to find this video so that they can also get help on calculus.